So this video will discuss even and odd functions, and we're going to show how we can differentiate between an even function or an odd function or neither. So there's an algebraic test that we use to determine if a function is even, odd, or neither. So we substitute in negative x in for x everywhere within the function, and then we just go ahead and analyze the results. Right? Since we substitute in negative x, we're actually doing f of negative x. So we plug that in everywhere we see an x, and we evaluate the function and compare it to the original function, the f of x function. So for an even function, when we plug in a negative value for x, and once doing that and analyzing it, if we get the original function back, f of x, then we can say it's even. However, if we plug in a negative function, negative x, into the function, analyze it, and then get the opposite of the original function, then we can say it's an odd function. If it doesn't fit any one of these two categories, then it's neither even nor odd. So let's go ahead and try some examples. Our first example is f of x is equal to x squared plus 4. So we'd like to determine if this is even, odd, or neither. Even, odd, or neither. So as we stated, we're going to plug in a negative x in for x everywhere within the function. So we're going to take f of negative x. So I'll put in a negative x to the second power plus 4. So that's the only place we need to substitute is in for x. So what do we get? F of negative x is equal to, when you have a negative x raised to the second power, right? It's kind of like for us saying negative times another negative. We'll make this whole thing positive. So it becomes positive plus 4. So now let's take a look at this. We plugged in f of negative x, and what was our result? X squared plus 4. Well, if we look back to the original function was x squared plus 4. So we got the original function back. So we plugged in negative x and got the original function back. So we look up here, it looks like it fits the category for an even function. When you plug in for a negative x in for x, you get the original function back, and we'll say it's even. So we'll say f of x equals x squared plus 4 is an even function. It's an even function. All right, let's take a look at another example. If we have f of x is equal to x to the third minus 2x. All right, so our first step is to go ahead and plug in a negative x into x throughout the entire function. So negative x to the third minus 2 times negative x. So f of negative x is equal to, here let's think through it, a negative x to the third. So that'll be a negative times a negative times a negative, right? A negative times a negative times a negative. So those first two negatives make a positive, but then the positive times that third negative makes it a negative, x to the third. And then here, of course, negative 2 times negative x gives us a positive 2x. So let's take a close look at this. Here we have a negative x to the third and a positive 2x. Right? If we were to rewrite this, f of negative x, and perhaps we can already tell, pulling a negative on the outside of x to the third minus 2x, which was the original, means it's the opposite. Well, we can already tell that maybe from the previous step. Negative x to the third is the opposite of this positive x to the third in the original function. Positive 2x is the opposite of negative 2x. Or I can just choose to write it together and say the negative of this entire quantity, right? Which would give us the previous step back. But either way, it's the opposite. So we plugged in a negative x, and then we got a negative f of x, meaning the opposite. So that tells us, from looking back up into the categories, it looks to be an odd function. It looks to be an odd function because it says when you plug in a negative x, you'll get negative f of x, which is what we have received. So this is an odd function. F of x equals x to the third minus 2x is odd. All right, let's take a look at a third example. Our third example is f of x equals x to the second power minus 3x plus 4. In plugging in a negative x everywhere we see an x in the function, so negative x to the second minus 3 times negative x plus 4. F of negative x gets us negative x to the second. Thinking through it, it's like a negative times a negative, right? Which would result in a positive. Here, a negative 3 times a negative x is a positive 3x. And we bring down the plus 4. So we look at it and we say, did we receive the same original function? Not quite. The original function had a negative 3x. So it's not the original function, so we know it's not even. However, did we get the opposites? So x squared, it's not the opposite of that x squared. It's the same thing. The only opposite one was the 3x term. The 4's are the same as well, these constants. So all of them are not opposites, so it's definitely not the odd function. So now we'll say neither. It's not even nor odd. So this is the strategy that you would use in seeing if it was an even or odd function, right? Go ahead and plug in a negative x in for x throughout the entire function. Come back, see if you saw the exact same function. If so, it's even. If not, see if you see the opposite function. If so, then it's odd. If it doesn't fit one of those two, then you say neither one. So this was even and odd functions. I hope this helped you. Please share this with anyone who you think may be able to use it. Hit like if you choose and subscribe if you choose. Take care.